I'm Anil Kumar, and in this video we will learn the steps to calculate I to the power of n, where I is the complex part, I square is equals to minus 1, right? And where n belongs to set of integers, right? N belongs to set of integers. So we need to understand all these steps so that we can easily calculate I to the power of anything, and could be any integer, easily. So let us say we can try a few. Let's say we have I to the power of let's say 17, I to the power of, let's say 26, and we can say I to the power of let's say 105. So we have just taken random numbers. How to find the value of I to the power of 17, I to the power of 26, I to the power of 105, when we know that I square is minus 1. So these are the complex numbers. To solve this question, let us look into the pattern. So if I have n as 0, we'll look into positive numbers. If n is 0, then I to the power of 0, anything to the power of 0 is 1. I to the power of 1 will be I itself. I to the power of 2 is minus 1. And I to the power of 3 will be I squared times I, right? Will be I squared times I. So I could write this as minus I, is that okay? I to the power of 4 will be I cubed times I, right? So we can do that. Or we could do I squared times I squared. So let's write I squared times I squared. That is product of minus 1 with minus 1. That gives us plus 1. And if we continue this pattern, what we notice is I to the power of 5 will be I to the power of 4 times I to the power of 4 is 1, so it is I. So what we notice here, that the pattern actually is 1I minus 1 minus I, and this pattern repeats after every 4 terms, right? So what we see here is a pattern. So in our case, the pattern is when the value of n moves from 0, 1, 2, 3 to 4, like this, and so on, the I to the power of n will change from, let me write down these values, as we saw here, 1I minus 1 minus I, then again 1. So what we notice here is if the power is multiple of 4, it is always 1. And if it is more than 4, let's say 1, 2, or 3, it could be I minus 1 or minus I, correct? So in general, what we notice here is that I to the power of 4, any number k, is always equal to how much? Is always 1, correct? And then that helps us to find powers of any exponent of I. So we'll use this property and then find the powers, right? So the first one here is equal to I to the power of 17. I could write this as I to the power of 17 is 16 plus 1, right? So it is written as 16 plus 1. The idea of writing this as 16 is 4 times 4 is 16, right? So which is basically I to the power of 4 to the power of 16 is 4 times 4, right? Times plus 1 means just multiply by I, right? So what you get here is this portion is 1. So 1 times I is I. So what we notice is if these multiples, 4k multiples, that is always 1, right? So basically you're left with whatever comes after plus. Let's do it once again. We have I to the power of 26. I could write 26 as 4 times 6 is 24 plus 2. Do you get an idea? Now 4 times 6 is like a multiple of 4. So this portion, the first portion, is 1. So let me rewrite this as I to the power of 4 times 6 times I to the power of 2, I square. Now this first part is 1, right? So 1 times I square is minus 1. So we get minus 1 as our result, which happens to be this value. Do you see that? Now let's take one more example here. Now in this case, we'll again do the similar method. So the idea is to divide 105. I'm doing it in different ways by 4 and check what the remainder is. So 4 times 2 is 8. We get 25. 4 times 6 is 24. Remainder is 1, right? So that means that 105 could be written as equal to I times I to the power of 4 times 26 plus the remainder, which is 1, right? So first part is 1, right? So this part could be written as I to the power of 4 times 26. This is 1 times I to the power of 1, right? So we get just I as our answer. Since this part is 1, right? This is 1 times I. So we get I as our answer. Do you see that? So the trick here is to write the exponent as 4k plus r, right? So we'll write any exponent. So if we have in general I to the power of n, we'll write this as I to the power of 4k plus the remainder r, right? So the value will be equal to I to the power of r. So that is the kind of rule. So let me write down here. If you want to evaluate I to the power of n, we'll write n as I to the power of multiple of 4 with any number plus the remainder, whatever. If the remainder is 0, we get 1 as the answer, right? So that should be equal to I to the power of r, right? So that is the result which we have got from this exercise. So what you can do is you can simply divide this exponent by 4, and whatever remainder you get, this is our remainder for us. So I to the power of that remainder is your answer, correct? So that is the fastest way of evaluating exponent of the real part, which is iota. So iota to the power of n is equal to iota to the power of 4 times k plus r, where r is the remainder. So it is I to the power of r. Since I to the power of 4 times anything will always be 1, right? Will always be 1, correct? Will always be 1, this part. Is that okay? So I hope this helps you to understand so that you can easily evaluate any exponent of I. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.